Hi there. So we are talking about our circuit analysis session. So here on the screen, we are finding ways to generate reference voltages. And this time I'm using the Zener diode, although Zener diodes are seldom used because they are noisy. And also, if you want to generate a reference below 2 volts or something like that, so using Zener is not a viable option. So we are asked to analyze this circuit. So here you have this supply voltage, or then you use the resistor R that will draw the current I from the supply. And let's say you have a Zener diode connected in this fashion where cathode is connected to the one end of the resistor and anode is connected to the ground. So there is a voltage at this node. If that voltage is greater than the breakdown voltage Vz of the Zener diode, the current I will start flowing through this diode as well. So this current comes right here. So the voltage at this node is obviously the V minus I times R. Let's say call it like VZ, obviously, or VZ dash. So this voltage at this node, and if this VZ, or let's say the V1, let's call it V1. If this V1 is greater than VZ, then your Zener is forward dialed. Okay. And now this voltage is coming at the positive pin of the operational amplifier, or let's say an amplifier with open loop gain indicated with AOL, and the negative pin of this amplifier is short circuited to the output of this amplifier. And we say that this is, let's say, your voltage V1, this is voltage V2. And the way uh, your output of the amplifier is given as your gain is basically V output divided by VID, where VID is the difference between these two voltages. VID is V1 minus V2. Okay, that's it. So you can write here V out divided by V1 minus V2. So if the gain of this amplifier tends to be very, very high, you can say that the gain, or you can say that V out divided by VID is equal to AOL, or you can write V out is equal to AOL times VID, that is the gain. But now you have the feedback here. So the feedback gain will be written as ACL, okay? ACL here, because that's the closed loop gain. AOL is an open loop gain, right? So if your gain in this case, if it is very high, uh, in ideally infinity, that means the difference between the two inputs should be zero. Okay. And for that, that mandates V1 should be equal to V2. So V2 comes at the same potential. The voltage can come here, and this, which is V1, and V1 is equal to VZ, and Vz therefore comes right here at output. So you say that V out is equal to Vz, and this circuit is called as voltage follower. Voltage follower, it means output voltage is following the input voltage. Voltage output is Vz and input voltage is Vz, because the diode gets into the conduction in the reverse bias. The voltage at the cathode is greater than Vz, the reverse breakdown voltage of the Zener. So that's how you actually see that. So now coming back to this equation, we know that uh, gain of the circuit, we say that V out is equal to V input or VZ actually, right? And yeah, so the output ratio of output divided by input, which is actually VZ, is equal to your closed loop gain, which is equal to V out, and V input, uh, V your V out is nothing but now V in, which is VZ, and V in the ratio, which is equal to 1. So closed loop gain of the circuit is 1. So you see the open loop gain of the amplifier help us to make sure that the voltages VID, or the difference between the two voltages VID, is approximately equal to 0, ideally 0. And therefore, with that, by shorting output back to input, we have this closed loop gain equal to 1, where the circuit works as a voltage follower. It is also called as voltage buffer. The characteristics of this, that the input impedance is very high, that is C in of this circuit. Let's say this is your buffer. So the input impedance is very high and the output impedance Z out is very low. Output impedance very low. So that's it. That's the characteristic. So it means the Z in of the circuit is very high and Z out of the circuit is very low. So input impedance Z in is very high. It means we require a very low current to drive this circuit. And output impedance is very low. It means the circuit at the output of op-amp, the output of op-amp has the capability to drive any amount of load, or load requiring any amount of current. So hope you understood this video about generating the reference with the help of Zener, diode, resistor, and one amplifier. However, there are some other factors, such as you want your reference to be stable against variation in the supply, against variations in the temperature, against variation in the load. So those are 3 other aspects that one needs to explore and find solution. And so stay tuned for information about